Last time when we discussed circles, we said that if you have a circle and it's split here by 2 radii, a new sector is formed. So this shape is a sector. It's called a sector. There is a way of calculating the area of a sector, and it's the same method could be used to find the arc length. The arc is mainly the curve, this only. This is what we call an arc. But the sector is the whole shaded with black region. So what's that method? The method is mainly you need to use this angle, let's call it A, and you need to use this radius. If you do have the angle and the radius, you'll get everything you need, whether it's the area or the arc length. How? By just putting the angle over 360, which is the whole degree measure of a full circle. So this angle over 360 is supposed to be equal to the area of the sector over the whole area of the circle, which is pi r squared. And again, the same rule, the angle over 360 would be equal to the length of the arc over the length of the whole circle, which is 2 pi r. So the upper rule goes for the area, the lower one goes for the arc. Does that make sense so far? Do we have any problems in this one?
Mr.
Yes.
ممكن نقول ان باي ار سكوير multiplied by الانجل over 360 على طول ده الاريا of the sector.
It's true. I wanted you to know it this way best so that you can tell in this ratio is the whole thing. The ratio between the angle and the whole angles is everything. It's the same ratio that's between the area of the sector and the whole area. Or it's the same ratio that's equal to the arc length over the length of the whole thing. So what you're talking about is the next step. It's like, if I need to find A, what should I do? Then this means that A will be equal, sorry, not A. If I need to find X, what should I do? This means that I'm supposed to multiply the angle by the area and then divide this by 360. It's the same thing. And over here, if I need to get the X, I'll multiply the angle by the circumference and then again over 360. So in other words, it's like you're taking this ratio, which is the angle over 360, and you multiply that by either the area or the circumference. It depends on whether you need the area or the length. If you need the area, you'll use this one, and if you need the length, you'll use the circumference. Makes sense? All clear, ya jama'a? Thank you, Habibi. Everyone else was all good? This is extremely important to me and for you to understand that at the end of the day, this is considered a ratio, not just a rule. It's a ratio. How do I find the ratio between any two things? Just by dividing them. So when we divide the angle by the whole angles, it's like we're getting the ratio of this tiny angle over the whole circle, to the whole circle. So that's the part that has to do with the area of the sector and the arc length. Now I'd like to discuss with you what we call special triangles. So the special triangles are mainly triangles with specific measures for the angles and the sides, and they're repeated a lot, or they exist a lot in reality and in real life, so we care about them, and that's why we call them special triangles. These two special triangles look like this. One of them, first of all, both are right triangles. So both special triangles are right triangles. One of them has angles of 45 and 45, and the other one has angles of 30 degrees and 60 degrees and 90. So yes, 45, 45 and 30, 60, 90, exactly. So the 45, 45 degrees, what does that tell me? If you remember when we discussed the isosceles triangle in the previous lesson, we were talking that there are types of triangles, and one type of the triangle was called an isosceles triangle. And the isosceles triangle, the whole thing about it is that whenever we have two angles that are equal, this means that the two sides in front of them are equal as well. So it's either the sides are equal, and I'll know right away that the angles as well are equal, or the other way around. They'll tell me that the angles are equal, and I'll deduce, sorry, that the sides are equal as well. So over here, this is apparently an isosceles triangle, which means if this side is equals to x, the other side will be x as well. So the theory here says that the side in front of the 90, which is the hypotenuse, in this case only will become x multiplied by root 2. What do we mean by that, and how is that ever used? So you'll be given a triangle, or you'll be shown a triangle where one angle of this triangle is 45 degrees. And you may be given this side, for example, with 10. You want to find the measure of this one, the hypotenuse. Now you look at the triangle, you realize it's a right triangle, and you realize that one of them is 45, which means right away that the other side angle, will be 45 degrees as well. That means that if this is 10, this one is 10 as well. That means that this is a special triangle. What should we do? If this is x, this is x, this is x root 2. So if this is 10, this is 10, this is supposed to be 10 root 2. And that is the value of x now, 10 root 2. So whatever the value of this side, it's the same as the value of that side, and it's the same as the hypotenuse, but multiplied by root 2.
Mr. عندي سؤال.
Sure.
كان في سؤال كده بيقول لك square.
Yeah.
It has a diagonal line of 2 over root 2 أو root 2 over 2.
Yes.
وبعدين بيسألك what was the side length. ففي الآخر الإجابة كانت half. بس مش عارف لو ليها.
It works on this. Let's see how. I'll show you برضه how on another example. So what you're talking about is a case where you're given, instead of a triangle, you're given a square. And we know that the square has all its sides equal to each other, and all of its angles are equals to 90 degrees. Then they told you that the diagonal of that square, which is this side here, has a length of 2 root 2. What were they asking you to find?
لا, it has a length of 2 over root 2.
Okay.
أو root 2 over 2. مش فاكر كانت أي واحدة.
Let's say it's root 2 over 2. Okay. Now,
كان بيقول لك what's the side length?
What's the measure of this side? So because we know that this is a square, we know if this is x, this one should be x as well. And that one, which is the hypotenuse, should be, according to the formula, x root 2. Now take this and solve it as an equation. X root 2 is supposed to be equals to root 2 over 2. Now let's try to find the value of x by moving root 2 to the other side by division. So x will be equals to root 2 over 2 multiplied by root 2. These will cross each other, and the remaining will be just half. So that is the length of the side of the square. Does that make sense, Ya Omar?
أيوة ماشي.
Everyone, is this clear?
Mister, I get it all. I just have one question.
Sure.
So every time it's going to be 10 square root 2, right?
It's not 10. It could be, if this side is 5, then this side will be 5, and then this side will be 5 root 2.
And then x is equals to 5 root 2. So if you get a question asking you what x is or something like that, it's going to be 5 root 2.
No, try to explain more to me what you're trying to say.
What I'm trying to ask is, why do we need 5 root 2? That's what I don't get.
It's not that we need it. It depends on the question. So if, for example, you're given a question that says that this angle is 45, and you know that the hypotenuse, or they gave you the hypotenuse equals to 10, for example. Let's say not 10 because you think 10 is a constant number. Let's say it's 6. You asked for one reason or another to find the value of this side here. Okay, so what do you know about those special triangles? What we know is that if this is 45, this must be 45 as well. and that if this is x, this should be x, and this should be x root 2. Is that correct?
Yes.
So according to what they gave me, the x root 2, or the side that's supposed to be x root 2, is actually here equals to 6. So if I need to find the value of x, I'll just move root 2 to the other side with division. In this case, x will be equals to 6 root 2.
Okay, I got it.
Sure?
Yes.
Now, on the other hand, the other triangle, the 30-60 triangle, has a different formula there. If the side in front of the 30, the side opposite to the 30 degrees is x, then the hypotenuse should become 2x. In this case, the side in front of the 60 will become x root 3. This has to be memorized. So how can we see an example on this? So let's say you're given this triangle here. You're told that this angle is 30. You're also told or given that this side is equals to 8. You are asked to find the length of this side here. So how do we solve this? We think, if this is a right triangle and we have 30 degrees, this means that this one is 60 degrees. This means it is a special triangle. What do I know about the special triangles? Is that the side in front of the 30, if it is x, then the one that's the hypotenuse is supposed to be 2x. Then the one in front of the 60 is supposed to be x root 3. So what am I given now? I'm given that the 2x is equals to 8. If I need to find x, this means it will be equals to 4. So what's wanted? Is it this side? Then it's 4. If I want this side, it will become 4 root 3. Does that make sense?
Yes, Miss, I got it in the questions.
Everyone else, is this clear? Awesome. So these are the special triangles that I want you to remember. They could be given on their own كده triangle لوحده, and it's clear. And sometimes, as we showed you, or as Omar as well actually explained, that he saw it in one of the questions, that the triangle is inside the square. It's fine as long as there is a triangle somewhere and it has those characteristics, those angles, and those measures of sides. This theory works. So right after the special triangles, we will discuss the law of sines and the law of cosines. We'll start with the law of sines. Now, the important thing to know about the law of sines is that it does not apply on right triangles. So law of sines can be applied on scalene triangles, which means all the angles are not equal. It could be also applied on isosceles triangles. It could be applied on equilateral triangles, but it doesn't make sense, of course, to apply it on equilateral triangles, but it could be applied, it will work. The only thing that does not work with it is that it does not work with right triangles. So if there is a 90 degrees there, we know for a fact that we're not thinking of the law of sines. So what does it say? The law of sines says that if you have a triangle like this one with various sides with different measures, and you're told that this side is A, actually no, this angle is A, this angle is B, this angle is C. The side in front of angle C is a capital C. The side in front of angle C is a small c. And the side in front of capital A is small a. And the side in front of capital B is small b. I'll write the rule and then I'll try to explain it in a way that makes more sense. Okay? So what does the rule say? The rule says we're supposed to put sine any angle over its opposite side, and it's supposed to be equal to sine any other angle over its opposite side, or any other angle over its opposite side. So the easiest way to think about this is we need a sine of an angle over its opposite side. That's what it is. And you keep putting each angle over its opposite side. Whatever is missing, you should be able to find back. Like how? What is it that what do I mean by that? So for example, if you're given a triangle like this one, you're told that this angle is 30 degrees, you're told that this side is 10, you're told that this one is 50 degrees. And you need to find the value of this side. So we ask ourselves, what do we have? Do we have a side, an angle, and its opposite side? Do we have this main important thing, an angle and its opposite side? Yes, we do. Because we have the measure of this angle and we have the measure of its opposite side. So we'll write part of the rule that says sine the angle over its opposite side should be equals to sine any other angle, which in this case is the 50, over its opposite side, which is in this case x. So if I need to find x, I'll just cross multiply. X in this case will be equals to 10 multiplied by sine 50 over sine 30. And that could be easily calculated on a calculator and you get your answer. Does that make sense? Oh, things like that. Everyone, are we clear? Awesome. So what is then the law of cosines? Again, the law of cosines only applies when it's not a right triangle. So what does the rule says? It says that if you have, again, a scalene triangle that has 3 different measures of angles and sides, and again, if the side in front of angle A is called small a, small c, and small b, the rule says any side to the power of 2 is equals to the 2 other sides added to the power of 2 minus 2 multiplied by the 2 sides cosine the middle angle. When do we use the law of cosines? When we have 2 given sides and 1 middle angle. And when do we use the law of cosines? When we have 1 angle and 1 opposite side. This is when to use the law of sines, and this is when to use the law of cosines. So how could this be applied in an example? So if you do have, let's say, a triangle like this one, you're told that this is 10, this is 15, and you're told that this angle is 40 degrees, let's say. You want to find the length of this side. So I'll show you. If this is, do we have 2 sides and 1 middle angle? Yes, we have these 2 sides and the middle angle right between them both. So how do we find x? X to the power of 2 is supposed to be equals to these 2 sides squared, 10 power 2 plus 15 power 2, minus 2 multiplied by the same 2 sides, then multiplied by cosine the middle angle, which is the 40. So if I want to know the actual value of x alone, I'll just put a square root and I'll write this whole thing on a calculator. By the way, this could be an incorrect answer because these numbers are numbers that I assumed. It may be not true for a real triangle, but the theory is this is how it works. If you do have any 2 sides and its middle angle and you want to know the opposite third side, I'll just apply the rule right away. Please ask if you have questions in this one now.
Mr. Ahmed,
Yes, please.
my laptop crashed and I only got the last bit. Is it fine if you could just quickly explain it to me again?
Yes, so what we're saying is mainly if we do have a triangle that's not a right triangle, and we do have two given sides and one middle angle. So instead of having a side and angle in front of each other or opposite to each other, we now have two given sides, just like this example here, two sides, and the middle angle between them. We do not have an opposite side and angle. In this case, we'll use the cosine law. What does the cosine law says? It says this. If you take any side whatsoever and you put it to the power of 2, it's supposed to be equal to the two other sides squared added to each other minus 2 times both the same sides multiplied by cosine the angle, the middle angle between them, which is b. So when we applied this rule over here, we said that this side is squared is supposed to be equal to the two other sides that are 10 and 15 squared minus 2 times 10 and 15 cosine the middle angle. So if I need to actually remove the power of 2, I'll just have to put a square root all over the other side. So on a calculator, you will just have to put this and it should get me an answer. I also said if for some reason this did not get you a correct answer, it's because I assumed those numbers. They may be not true or not does not apply for an actual real triangle. Does that make sense, Ya Ali?
Yes, Mr. Thank you.
Everyone else? Similarity. How does the similarity thing work? It works whenever we have two shapes that have the same angles but not the same measures of the sides. Jed, you mean if it's any other side? You mean if I need to find c squared, then it will be equals to the other two sides squared minus 2 multiplied by the same two sides cosine the middle angle. If I need to find a squared, it will be equals to the other two sides squared minus 2 times the same two sides cosine the middle angle. Is that your question? Or Jed, you're talking about something else? Oh yeah, what's wrong with the law of sines? If I need to find, let's say, c, I'll cross multiply these two. So I have to have this side and this side and this angle at least. If I needed to find any other, so you just have to have at least 3 out of these 4 parts. You have to have an angle and its opposite side, and then either an angle or a side, and you'll be able to get whatever is missing. Is that the question? Because I don't really get that. Yeah. To what, ya Habib? I told you to what? Yes, you need one side and its up. If you have one side and its opposite angle, then this means that the law of sines could be applied. Now, what do you actually need in order to substitute and find any missing part? You need must have at least a side and its opposite angle, along with either side or an angle to get anything else that's missing. Does that make sense? In the law, okay, yes, sure. So in the law of cosines, Yahya is asking another question. In the law of cosines, what if we need to find the angle itself? So what if we have the 3 sides like this? So if that happened, then you need to find, like, let's say this angle here. Then you'll take any side and you'll say that this side squared is supposed to be equal to the two other sides squared minus 2 multiplied by the two sides multiplied by cosine the angle that I don't know, which is x. Now, how do I find x? Solve this as an equation. This will be 100, 225, 144, negative 360 cosine x. Then add these two, 369 minus 360 cosine x. Move 369 to the other side by subtraction. You'll have negative 269 equals to negative 360 cosine x. Then move this to the other side by division. So cosine x will be equals to this divided by that. And then do shift cosine. This fraction, it will get you the value of x. Does that answer the question يا يحيى؟
بس انا كنت بعملها بطريقه مختلفه شويه في المدرسه. احنا كنا بنعمل
الرول اصلا
نودي ال 15 في الباور اوف 2 و 12 في الباور اوف 2 الناحيه الثانيه.
ايوه بتعمل الرول، يعني تبقى حافظ لها رول صح؟ حافظ لها رول الثانيه صح؟ ان هي اللي هو ان b is equals to shift cosine b squared minus a squared minus c squared over negative 2ac.
ايوه وبعدين بعد ما نخلص نعمل لها شيفت كوزاين وفعلا
هي بالظبط فاهم. انا بس مش عايزك اخليك تحفظهم as two different rules. I want you to memorize them as one وتجيب منه اللي انت عايزه، لانه don't load your mind with too many rules. You won't remember them all. فاهم؟ Any questions about those? Type. What about the similarity? As I was saying, the similarity, whenever we have two triangles with the same measures of the angles, but with different lengths of the sides. So what happens when I know that these triangles are similar? What happens is that there is a small triangle and there's a bigger triangle. Now, if you took in any similar triangles, if you took any of the small sides, like for example this one, over the corresponding side في الكبير, like AB, is supposed to be equals to any other side في الصغير, let's say XZ, over its corresponding side in the bigger triangle, which means it's AC, equals to BC, sorry, YZ, the small side, over its corresponding side in the other triangle, which is BC. So how again does this work? Let's say you'll have two triangles inside of each other like those, and you're told, or you can tell, that these are actually similar triangles. So this big triangle ACE is similar to the small triangle BDC, this small one. If you took any of the smaller sides, like for example BD, over اللي زيه, which is AE, it's supposed to be equal to, let's say, BC over the one that's similar to it, which is AC entirely. And it's supposed to be equals to DC, which is this small side, over the entire bigger side that's similar to it, which is EC. So whatever is given, if you have like at least three of those, you can get whatever the third one by just cross multiplying. Does this one make sense? No?
Mr. I just have a question.
Yeah.
So it's just the shorter one over the smaller one, like
over
BD,
the
over the. So it's the shorter one over the larger one. Like
yes.
BD is the shorter line and ACE is the biggest one.
Exactly.
And you do that
for any of them.
انا لسه كان ممكن احط اللارجر one above the smaller صح؟
Yes,
عادي.
ينفع. The problem best with it is that if the bigger one and the smaller one like are divisible, divisible. So if the bigger one is 10 and the smaller one is 5, 10 over 5 will get you 2. You'll get stuck here and you won't know what to cross multiply with and so on. So عشان كده I always tell you put the smaller one over the bigger one so that it remains as a fraction and you'd be able to cross multiply. طيب. Let's see some of the examples, okay? So this one. So if you clicked on the link on Google Classroom, the one that says P3 geometry, not P3 circuits, P3 geometry part, these are a total of 6 questions. They're all about sines, cosines. They're about similarity. They're about area of shaded region. They're about exterior angles. So it's all about the geometry again that we've covered, except the circles. Once we're done with it, inshallah, I'll take you through some of the other examples in triangles and then the circles, but without the equations. So whenever you're ready, please go to P3 geometry. In this one, apparently it's a right triangle. All the answers have either sine or cosine, so I'm thinking in that direction right away. Just because I looked at the time, that's what I can see. Also because I have an angle and a side in a right triangle, then this means I do have the opposite side to the angle 40. And apparently they want me to find the side or the length of side BC, which is this one, which is the hypotenuse. So what has the hypotenuse and an opposite into its ratio? It's the sine. So then sine this angle of 40 is supposed to be equals to the opposite over the hypotenuse, which is BC. Now, if I need to find BC, it should be equals to 3 divided by sine 40. So this means that the answer is C. Does that make sense?
Yes, Mr. I just have a question.
Of course.
So, Mr., if I get a question like this as an example, and they want me to get the hypotenuse,
yep.
I use the line 3 over sine and the angle, right?
So here's how it goes. You do have 3 things, Yani. It's mainly, it's always either sine or cosine or tan, right? Equals to whether it's the opposite or the adjacent, or whether it's opposite over the adjacent or the hypotenuse here. So it goes like the sine of something is equals to the opposite over hypotenuse. Now, if you need to find the hypotenuse, you'll do the opposite divided by the sine. If you need to find the sine, you'll do the opposite divided the hypotenuse. If you need to find the opposite, you'll do the sine times the hypotenuse. So if they're next to each other, you'll multiply them. If they're over each other, you'll divide them. That's one way to look at it. Another way is because you need to find BC, which is in the denominator, it will go to the other side first with multiplication. So it will be BC sine 40 equals to 3. Then this sine 40 will need to go to the other side with division. So I'll have BC equals to 3 over sine 40, which is the same thing. So you either memorize it this way or you better understand it that way, however you prefer. Does that answer your question, or this is irrelevant?
Yes, it's the triangle.
Perfect. Most welcome. Now moving on to number 20, or it was number 2 actually in the question. So in triangle ABC, you're given already the sine of the angle C. This is the angle C apparently. And you're given that the sine of angle C is equals to 0.5. Now, we know about the sines and the cosines and so on that they are fractions. So let's change this to fraction just to keep it in the form that we're used to, which is 1 over 2. So half 0.5 is the same as 1 over 2. If that's the case, we can assume that this is the opposite and this is the hypotenuse, because the sine is supposed to be equals to opposite over hypotenuse. Which means that if AB is equals to 1, then AC must be equals to 2. He's asking what's the measure of angle A? What's the measure of this angle? Now, if I need to find the angle itself, what's the measure of the angle itself? If I need to find C itself, when I already have its sine, I just need to move the sign to the other side by shift sign on a calculator of 0.5. So if you want to move the sign to the other side, it doesn't go with division. It goes as sign to the power of -1, which is the same as division, by the way. So you do it as shift sign -1, shift sign, sorry, 0.5. And that would get me the value of C equals to 30 degrees. So the measure of this angle is 30 degrees. If this is 30, this is 90, then this must be 60 degrees, which is mainly 180 minus 90 and minus 30. That's how I got the answer of 60 degrees. So the answer here is that angle A is equals to 60. No. 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 يا اما كالكوليتر، يا اما هتجيلك في كالكوليتر سكشن، يا اما لو مش موجوده في كالكوليتر سكشن هو الهاف دي الوحيده اللي سهله بصراحه، يعني المفروض تبقى محفوظه عادي because of the special triangles that we discussed earlier. لان انت لو بصيت على اي special triangle 30 60 اهو، الساين بتاعت الانجل 30 المفروض تكون opposite over hypotenuse which is x over 2x، يعني half. فعلى طول ساين ال 30 هتبقى بهاف. اوكي. Now if you check this, if x and y are positive measures of acute angles, sine something is equals to cosine something else. Is asking what is the possible value of x plus y. Now, what I know, whenever we have, according to the rule we discussed earlier, whenever we have sine something equals to cosine something else, that means that these two angles are added to each other equals to 90. So that's what I'm going to do here. Isn't it sine this plus, sorry, equals to cosine this? That means that x minus 20 plus y plus 12 is supposed to be equals to 90 degrees. Now, since they want me to only have x plus y, I'll just remove the negative 20 and the 12 and move them to the other side. That would get me 90 plus 20 and then minus 12. That would get me x plus y equals to 110 minus 12, sorry, 110, what is it? 90 plus 20 is 110 minus 12, it's just 98. So this is x plus y. Does that make sense? Yes, 98. This is the type of question, and the reason why I explained this rule earlier is that whenever we have sine of one angle equals to cosine of anything else, these two things added to each other must be equals to 90. Now moving on to this. This is a shaded region, and if you remember when I told you about the shaded region, I told you we have to get the area of something big and remove from it something else. That's whenever we have shaded region. So there will be two areas that must be subtracted. So he's here telling me that fi is equals to 4, so the radius is 4, which means this one also is 4. You're told that jhi, which is this angle here, is equal to jih, which is this angle there, and they're both equals to 45 degrees. What is the area of this shaded region? There are two ways to get this. The easiest one is to actually split this and start looking at this in a different way. Because if you drew this line, this is a radius, so it must have the same lengths as this radius as well. So if this is 45, this must be 45, and this must be 90. Now I can easily get the area of this triangle here, because the area of a triangle is half times base times height. And I do have the base with 4 and the height with 4 as well. So that's half times 4 times 4. This is the area of the right triangle, which is 8. How do I use the area of this right triangle? If you now please look at this whole sector, this is considered quarter of a circle. What do I mean by quarter of a circle? It's that it's a circle but divided by 4. So the area of this part is the area of the circle but divided by 4. So what's the area of the circle? It's actually pi 4 to the power of 2. Still, it must be divided by 4, which means the answer here is 4 pi. This is the area of the whole sector. if I need to find just the shaded region, I'll subtract from the sector the triangle, which is 8. Once you do that, you'll get this form here, which is C. Please ask about this one if you're a tiny bit confused.
بس طلع لحد half times base times height اتلخبطت شوية.
ده أولها. طيب ماشي. أوكي. خلينا نقولها كده تاني، ناخدها واحدة واحدة ون realize. So looking at the whole thing, yeah, from the very beginning, we saw a shaded region, which means then that we have to first get the area of this entire sector and then remove from it this triangle here. This will leave me with the area of the shaded region. Is that true? So that's the plan. Now, how do I get the area of this entire sector? So if you look at what's given, this is 4, which is a radius, which means this is 4 as well, right? Type, isn't this 90 degrees for sure, which means that this sector is the quarter of a circle, right?
بس مش هي كده المفروض تكون 4 بعديها روت 2.
لا، الهايبوتنس هو اللي ب 4 روت 2. قدام ال 90 ده اللي ب 4 روت 2. انا مش فارق معايا الهايبوتنس، انا بتكلم على this whole sector كده. مش ده يعتبر ربع سيركل؟ So how do I get the area of quarter of a circle? I'll get the area of the circle itself, which is pi 4 squared, and then divided by 4. That will get me 16 pi over 4, which is mainly 4 pi.
مش هي المفروض يا مستر 45 over 360 بعديها pi r squared times pi r squared.
لا ركز كويس قوي. Now اللي انت بتقوله ده المفروض اخد الانجل اللي هنا اساسا، اللي هي 90 degrees، مش اخد ال 45 صح؟ فال 90 degrees over 360 يعني 1 over 4. عشان كده بقول لك هو عشان دي 90 degrees انا عارف على طول انها ربع سيركل. ليه اخش في قصه ان انا اجيب الاريا سبيسيفيكلي بتاعت الحته دي؟ فاهم الفرق؟ فانا ببص عليها اوفرول، دي ربع سيركل كانها زي نص سيركل. سو ربع سيركل ده يعني الاريا بتاعت السيركل عادي وال divided by 4. That's the quarter of a circle صح؟ Now انا عايز اشيل من الكورتر اوف ذا سيركل ده الاريا بتاعت التراينجل الابيض اللي هو الحته دي بس صح؟ عشان يتبقى لي الشيدد. لا عشان لا مش ماينس 8، عشان يتبقى لي الشيدد. ال8 دي جبتها منين الشيدد؟ ال8 دي عشان الاريا بتاعت التراينجل هاف تايمز بيس تايمز هايت، وادي هاف وادي البيس ب 4 والهايت ب 4. سو ات ويل كم اوت، عشان كده طلعت ب 8 مش عشان هي مثلا 4 بلس 4 او كده صح؟ سو ناو عرفت خلاص دي 8. حلو، هعمل ال 4 باي اللي هي الكوارتر اوف ذا سيركل، اشيل منها التراينجل اللي ب 8 كده اداني the entire area of the shaded region صح؟
عملتها بطريقه ثانيه كده.
طيب اللي انت بقى بتقوله ممكن اعمله it will work as well. يعني if you decided ان this is 90 then المفروض ان 90 over 360 times the area of the circle which is pi 4 squared should give you the area of the sector which is still 4 pi برضه. دي برضه الكورتر اوف ذا سيركل. طيب دلوقتي بعد ما جبت الكورتر اوف ذا سيركل اعمل ايه بعد كده؟ محتاج اجيب الاريا اوف ذا تراينجل، وبرضه الاريا اوف ذا تراينجل غصب عني will become half times base times height which is half times 4 times 4 which is mainly 8. So you'll have to remove من ده.
ممكن اجيب الانسر لان هي 4 باي بس.
بالظبط، هو الوحيده اللي ب 4 باي كده. بس لا، نصيحه برضو بلاش تعمل كده لان ممكن تبقى divided by 2 بعد كده مثلا for a reason. ممكن يحصل حاجه ما تبقاش بقى انت في دماغك فاهم.
اصل انا كنت بعملها area of a sector minus area of triangle بعدين تطلع لي.
طب ما هو كده صح.
بعدين يطلع لي area of segment. بس انا عملتها 45 over 360.
لانك you assumed ان السنترال انجل هي ال 45. لا، السنترال انجل هي اللي عند السنتر مش اللي في الجنب. بس عفوا everyone else is it okay. This one is all about similarity clearly. So أول ما أشوف المنظر ده ببقى عارف الموضوع similarity. It's all about similarity. So what is it? This means that this side here, the smaller one اللي هو ال ED over the bigger side اللي هو AB is supposed to be equal to the smaller side اللي هو EC over AC equals to DC over BC. So this is just by looking at the question or the shape. Now what am I given? I'm given BC, this one, with 24. So it's actually now DC over 24. I'm also given AC, this one with 26. So this is EC. I'm also given ED with 8, this one, 8. Now, what is it that they want? They want EC, this one. What do you guys think? What did you guys do? I want to discuss this with you.
أنا يا مستر عملت حركة غبية بس قلت أجرب يعني.
لا مفيش حاجة غبية، قول.
أنا قلت يعني إن لو هم قالوا إيه دي اسبلنت to A B فقلت لهم equal to each other. أنا
لا ما تقدرش. It's
مستر
impossible
معلش
أصلا إن
بقى.
هم يبقوا equal عشان حتى واحد بادي في الأول والتاني نزل شوية تحت فأكيد صغر.
طيب
مستر هو أنت يعني لو AC كانت 24 يبقى كانت هتبقى اسمه إيه؟ كانت هتبقى BA equals ل 8 صح؟ فإحنا يعني ما ينفعش. أنا مثلا لو ده دايما بيشتغل لا ينفع ناخد التول اكسترا ده ونعمل لهم اد
لا
على عشان انا كنت بعمل كده في امتحانات كتير بس ساعات بتطلع صح ساعات بتطلع غلط بس هنا متهيألي انت المفروض تستعمل البايثاغورس ثيرم بس انا بسأل ان جنرال يعني عشان دي سنتد ففي تو اكسترا ما ينفعش احطهم على اللاين اللي ورا ده.
You can't unfortunately. أنا فاهم أنت عايز تعمل إيه بس مش هتنفع. بص. So I'm given أهو هكتبهم على الشيب نفسه. This is 24. I'm also given أي حاجة من الحاجات دي كده بس هم التلاتة دول الحاجات اللي given. طيب part بقى by part بالراحة يعني. First of all المفروض يكون عندي at least one full fraction, the numerator and the denominator, in order to be able to cross multiply. So أنا محتاج what am I missing? I'm missing either AB أو EC أو DC. لو عندي أي حاجة منهم هعرف أجيب الباقي كله. So I'll think maybe I can get AB. ليه؟ لأنه when you look at the big triangle اللي هو A, B, C, this one, they told me here in the question itself is that they're a right triangle, which means that this is 90 degrees. If this is 90 degrees and I have the hypotenuse of 26 and I have one leg of 24, how can I get the measure of this one? So I'll refer to the Pythagorean theorem, which is mainly 26 the hypotenuse to the power of 2 minus the other side to the power of 2. That should get me an answer that's 18, 5, 10, 10. So I have this now equals to 10, which means I have now AB equals to 10, which means I can get whatever it is that I'm missing now. So if I want EC, I'll just cross multiply. I'll do 8 multiplied by 26 and then divided by 10. Put this on a calculator. It's 18.4. But let me check if 10 is true first, because I may have made a mistake here. No, it is 10 is true. So yes, this is it. Does that make sense?
طب مستر هي هتفرق لو انا عملتها مثلا دي سي وبي سي بعديها ايكوالز اي دي او اي بي ولا مش هيفرق؟
لا مش هتفرق خالص. مش هتفرق as long as ان الصغيرين فوق والكبار تحت. و as long as ان السايد الصغير هي اوفر الكبير اللي زيه مش اوفر اي سايد تاني من الترانزيت. So let's quickly كده go through how did things go and how did we think of the answer, what happened and everything from the very beginning. I want you to focus, please, not just on the procedures of the steps, or the steps or the calculations. I want you to understand where did we start and why did we do every single step. So just to start with, because I saw this shape, I realized right away that these are similar triangles. To what I know, this is what I started with. أول ما شفت التريانجل، أول ما شفت question, what I know about similar triangles is that the small sides, which is, let's say, ED, over the corresponding bigger sides, RAB, is equals to any other small side over the corresponding bigger side. And I wrote this, I just wrote the formula there. Because that's what I know, and let's say I didn't actually read anything else. I don't know if I'm given anything out of this or not. And then I started reading the question. When you read the question, they say that ABC is a right triangle at B. So I'm now thinking of this big triangle ABC, and I know that this means if it's a right triangle, this means that this angle right there is 90 degrees. They also told me that segment ED and this one are parallel, which means that this angle is also another 90 degrees, by the way. Now I looked at whatever is given. According to what they write here, BC, which is this entire length, this whole thing, is equals to 24. While AC, this other full side, is equals to 26, giving me ED, this one, equals to 8. So I substituted those given things into this formula that I've created. Since ED is given with 8, I just substituted 8. Since AC is given with 26, I put 26. And now since BC as well is given with 24, I put the 24. And now I can see clearly the missing sides, or the sides that I'm supposed to find. When I continued reading the question, they told me they need EC, so apparently this is the wanted part. So when I looked at this, I realized that I either need AB, so I can cross multiply, or I need DC, so I can cross multiply. When I looked at the triangle, the givens, I can tell that the bigger triangle is easier to maneuver because I do have the hypotenuse of the bigger triangle and I have another leg. That reminded me of the Pythagoras theorem. What does the Pythagoras theorem states? It states that if you have the hypotenuse itself and another leg, you just need to square them both and put them under a square root, and that would get you the measure of the third side, which is AB. So now instead of AB, I can substitute 10. Since I do have a full fraction now, if I need to find EC, it's extremely easy. I'll just cross multiply. It's 8 times 26 and then divided by 10. Once you do this on a calculator, it got me the answer. Actually, 8 times 26, not 24.
20.8.
Yes, it's 20.8. You got me the answer is 20.8. The previous one, I used a wrong number. I used 24 but 26. I got confused. So the answer in this case is 20.8. Does every step make sense and kind of lead to each other? Not just how they're solved. Again, you on your own should be able to get from those steps to the next one. All good? Finally, 17. You're given here a triangle. We've discussed too many things about the triangle. First of all, is that vertically opposite angles are equal to each other. So this one also could be told, or could be called 2y plus 20. We also took another information, is that this exterior angle is equal to the sum of these two other angles far away from it. And that's what we will use. So we'll say that 3x minus 10 is supposed to be equal to the x plus 8 plus the other angle, which is 100. And I can now solve this equation. So I'll move the x to this side, and I'll have 2x equals to 108 plus 10, which is 118. Then x will be now equals to 118 divided by 2, which means x is equals to 59. Since I now have the measure of x, they actually want me to find y. How do I find y? Substitute first of all the x with 59. So now I have 3 multiplied by 59 minus 10. 3 multiplied by 59 is 160, no, 150, 109, no, yes, 197 minus 10, that would get me 180, no, 177, yes, yes, true. So 177 minus 10 equals to 167. So this 167 is the measure of this angle here, which means this one should be 180 minus 167, which means it should be equals to 13. So then 2y plus 20 is supposed to be equals to 13. So 2y is supposed to be equals to negative 7, which means that y must be equals to negative 3.5, which is D.
مستر هو الاوتسايد انجل صح، احنا قلنا الاوتسايد انجل دايما قد
الاثنين اللي جوه بلس بعض.
ماشي.
Everyone, is this okay? Perfect, awesome, great, and everything. Now, if you do head, please to the one that says circles, P3 circles. This one is all about just the sectors and the arc lengths and so on. This has a total of 4 actually questions. The first 2 questions refer to the beginning, the information provided at the very beginning. The first 2 questions are all about one length and one area. The rest are mainly good questions where you reason through the idea of ratios in sectors. This one involves special triangles inside of a circle, and that's mainly it. For the 4 questions, a total of 5 minutes. Please make sure to finish within this time. Let's go. لا 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 لا. Because it's the same زي فكرة بالظبط السكتور over السيركل كلها. part of this angle is equivalent. هي نفس الكونسبت. Think about it كده. This tiny angle over the whole angles is equal to this tiny arc over the whole arc because they're هم بتوع بعض. فاهم؟ لا. طيب.
لا.
ماشي.
بطريقه اسهل يا مستر.
جو اهيد يا حبيبي قول لي.
هي اطول، انا عارف، انا فاهم دي، يعني عملتها كده، بس في اللي هو انا اقول ان انا عارف السيركمفرنس بتاعت الانجل 120 كلها.
يس.
اعملها عادي 2 باي ار واكمل عادي واجيب الار واعملها على الناحيه الثانيه برضه كده عشان اجيب الايه.
طبعا بس هي اطول. بس صح طبعا تنفع. طيب يا جماعة خليني explain it this way. You remember if I have an arc like this one and I need to find the arc length or area whatsoever, don't we do A over the whole circle, which is 360, and make that equals to this part, let's say it's X, over the whole circumference, which is 2 pi r. Is that okay for everyone? Does everyone understand this part? Now it's the exact same concept. The A has gotten smaller. So this A now over, instead of the whole circle, I'll just take over this region. So A over this whole region, which is 120, is supposed to be equal to this arc, which is 8, over the whole arc that's available here, which is 8 plus 7 plus 6 plus 5 plus 4, which is 30. So it's the exact same concept, but instead of done for a full circle, I'll do it for this tiny part. بدل ما يطلع actually circumference بكام, I don't need the circumference, ما أنا already عندي length of أو عندي circumference of this part only from A to B, which is 30, by adding them up. Does that make better sense? Yes or no? No. Okay. طيب. You all get the idea of this part. Wait, let me change that. This part of A, this angle A, over the whole green part is the main ratio. Isn't this what we've been trying to explain all along? And then كل اللي محتاجه is part over the total. I need a ratio between the angle and the whole thing. This is the exact same case. Part of the whole thing. So here's, instead of the whole thing being green, the green part, instead of it being a circle, a full circle, the green part is now just a sector. And A is just a tiny part of it, right here. So do you all still get the fact that this I don't know what color is this. The purple color over the green one is the most important ratio as well, just like how here the purple part over the green one is the most important ratio. Do you guys get this idea there? Again, here's the A. This A is over the whole green is the same fact or the same idea as this A over the whole green. Now, if you took this part over the whole circle, it's equivalent to exactly this part over the whole available part of the circle. I don't know how. Why is this? How does this sound a bit confusing? I don't know. So I know that the green part is all 120 in this circle, and I know that A is the missing part. I also know that this circumference is 8, and that the whole part of AB is given as 30. So cross multiplying should get you the value of A. No such question was there again in any other case. So there's no other example on the exact same theory, because it won't happen again. It's just testing the understanding of part over total, or the ratio, as I just explained at the beginning. So you can either ask questions, or there's nothing else I can say here that would make things a bit better. Questions? You do understand it? I hope so. Type number 4, finally. Now, there's more than one way we can solve this question. I suggest solving it using this. Splitting this triangle into 2 equal parts. If you do that, you know that this angle is 90 degrees, and you know that this 8 is considered the hypotenuse. No, I explained, Jad, that there are no other similar examples because it was not repeated again, the exact same example. The idea of ratios is present, but in different various types of questions. So it may not be applied in geometry again, it may be applied in something else or whatsoever. So I hope we'll find one when we're solving tests, but so far there aren't any similar ones. Again, for this one, please understand that I'm going to take this triangle and split it into 2 equal parts. And because I did that, I know that this angle is 90 degrees, and that I split now this angle into 2 equal parts. He gave me measure AOB with 120, so each separate part is mainly 60. This is 60 and this is 60. So now I have a triangle that looks like this, where this angle is 60 degrees, this one is 90 degrees, and that one is 8. Can I get the length of this side here, this part here? Yes, we can. We can get it through actually more than one way. We can get it through. We can, but we use the side note still. We can definitely. Yes, I did. Yes.
Does this count as a special triangle?
Yes, because it's 60 and 90 triangle, so definitely it is special. Yes, true. So if that's the case, you'll think if this is the 60, then this is the 30, then this is supposed to be x, and this is supposed to be x root 3, and this one is supposed to be 2x. If 2x then is equals to 8, this means that x must be equals to 4, which means this is 4, and this side here is 4 root 3, which means that this part is 4 root 3. This one is equal to that one, so that's another 4 root 3, which is a total of 8 root 3. This is one way to look at it. The other way is to deal with the whole triangle right away. When you know that this is 120, and you know that this is 8, you know that this one as well is 8 because it's a radius too. You need to find the measure of this side here. So the sine law does not apply, but the cosine law does actually, because we have now two sides and the middle angle. I'm sorry.
انا قصدي انا يعني مش السايد انجل 30 انا قمت واخد 30 ساين 30 over 8 وبعدين equals
You
sin
can انا كده
120.
بزود الستبس صح؟ بس you can بس انت هتبقى بتزود الستب. هو ده كل يعني انت كده عارف ان this is 120, so this means that this side is equals to this side, so this angle is equals to this angle. So 180 minus 120 is 60 divided by 2. This is 30 and this is 30. You can use the sine law, but by saying that sine 30 over 8 is equals to sine 120 over the missing side, or from the very beginning you could just say that this side is equals to the square root of 8 to the power of 2 plus 8 to the power of 2 minus 2 times 8 times 8 cosine 120 on a calculator. Put this and it will get you to the same answer, which is 8 root 3. In both cases, x will come out as 8 root 3. Actually, in the 3 cases so far. So there's one case where we split the shape into smaller triangles and deal with it with special triangles. There's another case to deal with it as a full triangle and use the cosine law right away. You can still deal with it as a full triangle, but instead of the cosine law, you can use the sine law by getting the measure of this angle first and then get whatever it is that's missing. All 3 ways make sense so far.
بس هو اسهل الطريقه هي اول طريقه صح؟
هي اسهل عشان ما فيش فيها ساينز وكوزاينز، فما فيش كالكوليشنز خالص. يعني السؤال ده لو من غير كالكوليتر هتعرف تحله، بس لو هو بكالكوليتر سوري لو من غير كالكوليتر وعايز تحله بساين وكوزاين اتس impossible unless you memorized الساين 30 بكام والساين 120 بكام.
بس هو عموما يعني بيبقى عملها باول طريقه يعني.
يعني ده رأيي، بس again انت المشكله ان انت في الامتحان it doesn't go how I prefer or you prefer, it goes how you remember whatever it is that links to your mind at the time is how you're going to solve it. It's good to know more than one way for that reason. Whatever clicks بقى at the time. ممكن تلاقي نفسك بتعمل the most hardest one بس this is what you remember at the time. Then it's the perfect thing to do at the time. خلاص. فاهم؟ So I can do something interesting for you. First of all, the class is over. You can just do the exit ticket. I'm now going